This is the second installment of Organic Chemistry for 0654 IGSCE Coordinated Science. Get excited, strap yourselves in, we're going in. First thing I want you to know about is alkanes and alkenes. What words can I write? I can write that alkenes are unsaturated. So the alkenes are, of course, saturated. I can say that the general formula for an alkane is CnH2n plus 2. A general formula for an alkene is CnH2n. What on earth does that mean? That means for an alkene, whatever the C is, the H is double. Whatever the C is, the H is double. Whatever the C is, the H is double. Bosh. If it's an alkane on this side, we're going to have carbon and hydrogen and carbon and hydrogen and carbon and hydrogen. And whatever the carbon is, let's have 7, let's have 20, let's have 46. Okay, if it's 7, double 7, add 2, stop that, is 16. Come on. 7 times 2, add 2 is 16. 26 times 2 is 52, add 2 is 54. 46 times 2 is 92, add 2 is 94. Bingo, right? Easy. So given a list of these, you could work out which one was an alkane and which one was an alkene. So what other words do we need to know? Right, so this alkanes all have all single bonds. Alkenes have all double bonds. The first alkane, remember from the last video, Midgley eats pink biscuits. So the first alkane is CH4. Double, so 1 times 2 is 2 plus 2 is 4. 2 times 2 plus 2 is 6. C3, 2 times 3 is 6 plus 2 is 8. And 4, 2 times 4 is 8 plus 2 is 10. And you know that this is methane. You know that this is ethane. This is propane, not pentane. And this is butane. Jolly good. We did some combustion reactions with these in the previous video. I'm not going to repeat those. Basically, just to reiterate, we burned them and little else. Alkanes, pretty useful for keeping us warm and keeping cars going. Apart from that, pretty ditch dogweed stuff. So, alkenes. Alkenes, the methane is the first alkane. So can we have methane? No. Because an alkene has a C double bond C. You can't have a double bond to carbon from carbon if you only have one carbon. So methane does not exist. So ethene or ethene is the first alkene. Propene is the next one. And butene is the next one after that. So that's going to be CnH2n. So it's going to be C2H4. Propene, C3H6, and butene, C4H8. Okay, so you have C4H8. Beautiful. Right. What do we need to look at next? Methane, ethane, propane, butane. They also want you to know, you dear student, about these things called alcohols. And alcohols just means it has an OH group attached to an R group, where R equals, it could be CH3 or C2H5 or C3H7. Don't worry, it's just a hydrocarbon group. So we call those alkyl groups. Okay, so Midgley eats pink biscuits. So the first one would be H3C to OH, and then it's C2, so it's H5, OH, and it's C3, so it's H7, OH, and it's C4, and it's H9, OH. The mathematically minded amongst you will have already realised the general formula is CnH2n plus 1, OH. Beautiful. If it says what are alcohols used for, don't say it's to get older people drunk. It is not. Well, it is, but it's not. It's also used as a fuel. It fuels cars. The first one is meth, 1 carbon atom. Methanol, 1 carbon atom, 2 carbon atoms. Ethanol, This is the alcohol present in beer and wine and spirits and all those things which you don't do. Next one is propanol, and the last one is butanol. The OH group gives it the suffix ol. Okay. You need to be able to name up to carbons 4 for anes, enes, and ols. So this is up to 4 carbons: methanol, ethanol, propanol, butanol. And you need to know methane, ethane, propane, butane. No methane, but you do need to know ethene, propene, and butene. Okay. All of these, so all of these, by these I mean the alkanes, the alkenes, and the alcohols are all individual, homologous, tomato, who cares, homologous series. What's a homologous series? Well, a homologous series has similar chemical properties. So all alkanes burn to produce carbon dioxide and water. All alkenes add bromine, see the previous video, across the double bond. But there is a gradation in physical properties. What that means is, with increasing chain length, we have increasing boiling point. So if I plotted a graph and I had a boiling point here, and I had 1 carbon, 2 carbon, 3 carbon, 4, it would look something like that. So it's directly proportional. The more carbons you have in the chain, the higher the boiling point. So methane up here, methane, where have you gone? Here you are. Methane is a gas. This is a gas, this is a gas, this is a gas. If you go on to pentane, hexane is going to be liquid as you go down. So you get more higher intermolecular forces between neighbouring molecules as you add them. If you remember that we have similar chemical, there is a gradation in physical, and crucially for IGSCE, they want you to say that they differ by a CH2 unit. If it asks you what is a homologous series, just write differs by a CH2 unit. Okay, we mentioned alkanes and alkenes. Alkenes are saturated single bonds, alkenes are unsaturated double bonds. And where do we get the alkenes from? Well, last video, 1, 2, 3, 4, 5, we did fractional distillation. Separation on the basis of fractions. See my other video if you can't remember how to do that. And I said that at the top, we can make lots of money at the top from petrol and diesel and gases and all that good stuff. And this stuff, less crazy dollar. So we send these long hydrocarbon chains, so these are big, long molecules from the fractional distillation column. We send them for cracking. Woo! Let's do some cracking. So let's say we've got a really long 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're even longer than this, but I get bored quickly. Bish, bash, bosh. So all of these have hydrogen. My God, look at the state of that. All of these have hydrogen north and south. That's a bond. H, 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 H. Right, good. So this is shorter than what you get from the bottom of the column, but for all intents and purposes, this helps us enormously. If we crack it, but to crack it, we add heat and a catalyst. If I crack this, it's like using a pair of scissors and it will break a bond. It could break one there, okay? We could break one there, and if we break one there, we make an alkene and a shorter chain alkane. That's really good because now we've got ethene, mutually eats 2, and now we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got octane. Octane can be used as petrol, so now we can make some mad crazy dollar from this one. And ethene can do the 4 reactions of the alkenes, which I did in my previous video. Again, have a look at that if you are not sure. Now, who can remember the name of the alcohol which gets people drunk? C2H5OH. What was it used for? It's not used to get people drunk. It's used as a fuel. There are two routes you need to know to make this magical molecule. And this is ethene, and I can react it with, do you remember from my video, steam to make our CH3CH2OH. There's my ethanol. How else can we make ethanol? We can make ethanol, as the monks always did hundreds of years ago, by fermentation. Okay, so you take your sugar and your yeast, and then you make ethanol and CO2. So two methods to make alcohol. Okay, the main difficulty students have is this last topic, supplemental topic, is polymerization. Now there are two types. There is addition and condensation. And all of these come from crude oil. So if you're wearing any plastics, I'm sure you are, you wouldn't be if there wasn't for crude oil. Good crude oil, apart from killing all the birds and the fish and the animals. Right, so let's do addition first. So if we have C double bond C, and I touched on this in the previous video, and we have heat and a catalyst. If you're ever unsure, just write heat and catalyst over an arrow. Chemistry is quite forgiving. N monomers, remember that word? Monomers. A monomer is like one Lego brick. I'm going to make a big brick wall of lots of them. And then that double bond opens up. And this N here is the same number here, N there. So these are the repeat units. And this was ethene. And this is poly E. We don't say the E, do we? Polyethene or polythene. So that's plastic bags that you take from shopping, which you throw into the ocean and kill the dolphins. So that's ethene. The next methane, ethene, usually E is pink. So the next one is propene. So propene immediately E is pink. That's 3. There's 2 there. Just count to 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's our monomer, which is now propene. Propene monomer. And you might be tempted to say, well, 2 here went 2 there, so there's 3 here, so I'll go 1, 2, 3, bosh. You put your hydrogen in and put N, and then your examiner comes along and goes, no, cannot. And they are correct. And that previous answer was incorrect. Because what happens is the double bond breaks and it bonds to the next one. So what would happen is you get that kind of a situation going off into space. But as I said before, we are intelligent people. We do not need to draw the whole chain, but we need to draw the smallest subunit, which represents the whole chain. So make sure I've got my N there. In fact, let's do that in red. That seems to be a theme. N and N propene monomers here. And then I was putting my hydrogen, count to 4. 1, 2, 3, 4. 1, 2, 3, 4. Bish, bash, bosh. There we have one polymer of, propene. Thing to notice, if your bond does not extend beyond the bracket, you get no marks. So that's okay. That's okay. The carbon, this methyl group, is this one here, and that needs to be north of the chain. That's the only real difficulty with addition. Now condensation, this doesn't actually change. This is probably one of the hardest things that a student have to imagine, so I'll do it really quickly. So condensation is the formation of H2O. Okay, same as the condensation you would get on the morning grass in the dew as you are running through it. Same thing. What they try to do at GCSE, don't know why, don't think it helps, is instead of giving you some chemistry, they give you a shape. So this is a diamond, you know that's a diamond. And you're going to react this with some, let's react it with this stuff, and let's use a circle. NH2. Intelligent thing to notice is that these molecules have the same group of atoms twice. times 2. That means this end can react there, and this end can react here, and this end can react with that one, and so on and so forth. There's O, H, and H here. So we're going to make H2O, formation of H2O. So I'm going to remove my OH, H2O, and this did have a H here, that was NH2, and the bond goes there. The same thing happens at this side, H2, and that's going to be the H there. What's going to be the next atom? Well, it's going to be this one here, isn't it? So that's C double bond O to my diamond, and C double bond O. Then at this side, we're going to lose our OH. It's also going to make H2O. What's the next atom going to be? It's going to be N, H, circle. So we've got circle, diamond, circle, diamond. So if I just do a bracket there, C double bond O, and there, that represents the whole chain. At every bridge that we make one molecule of water. And this is nylon, so probably your shirt is made from nylon. Okay. Right, that kind of finishes the 0654 chemistry, alkanes, alkenes, no methane, alcohols, fermentation, a homologous series, fractional distillation, cracking, polymerization, addition, which can be a bit tricky, and condensation, probably the hardest thing you'll do at IGCSE. Hope you found that useful.